This is video 2 of looking at H-10, which is our notes over vector products or cross products, part 2. So we're just going to talk about this little piece right here in this video. So let's go back to the idea. So I have a picture here of what it geometrically means to have a cross product. So we have two vectors, A and B. So you can see those right here. And we've placed them so that they have their tails together, right? And so they determine a plane. And remember that the cross product is a vector that is perpendicular to that plane that contains those two vectors. So this is supposed to be three-dimensional. So think about A and B as being in the plane of the paper, and this is kind of sticking up perpendicular to the plane of the paper. And it can be varying lengths because there are infinitely many vectors that are perpendicular to that plane. So something that's important for you to know about this is, remember that we had this formula back when we did law of sines and law of cosines that gave us another formula for finding the area of a triangle. And the area of a triangle is, if I have this triangle ABC, and then if I have little a and little b and little c, then what this is saying is that I can find the area of the triangle by taking, it says 1/2 AB, so I'm going to take A times B, and notice those are the lengths of the sides, times the sine of angle C. And notice that C is the angle between those two sides, and that's important. So if we go over here, then if I turn this into a triangle by connecting the tips of these two vectors, then I do have a triangle, and this is my angle between them right here. And so I can say that the area of this triangle is going to be, using this formula, 1/2. Now, what I need here is the magnitude of this, right? Because this is the length. So I need the magnitude of A times the magnitude of B times the sine of the angle between them, which is theta. Okay? But notice what this is, all right? This is magnitude of A times the magnitude of B times the sine of theta. Let me highlight it so you can see it better. Magnitude of A times the magnitude of B times the sine of theta. Well, that is right here. And what is that? That's the magnitude of the cross product. So that means that this is going to be equal to 1/2 the magnitude of the cross product of A and B. It just comes right from the formula. So now, what else does this tell us? Well, if I multiply both sides of this by 2, so now I have the area of the triangle, and suppose I multiply both sides of this equation by 2, then I'm going to switch this. These will cancel, and I'm just left with the magnitude of the cross product is equal to 2 times the area of the triangle. Well, let's think about what that would be. If I take another triangle that's just like this one and put it here, okay, these have the same length, these have the same length, right? These have the same length. So we can see these two triangles are congruent to each other. So when we take 2 times the area of this triangle that's right here, then what we get is the area of this whole parallelogram, which is, let's try a different color here, which is right here. So this is the area of the parallelogram formed by A and B. Okay, so that's something that, might come in handy sometimes. So I just want to emphasize here then, when we talk about a cross product of two vectors, all right, remember that the direction of the cross product is perpendicular to the plane that contains vectors A and B. And then the magnitude of that vector is the area of the parallelogram that's formed by those two vectors. So we'll stop